Well, good morning, good afternoon, good evening, everybody. Happy Friday. Hope you're having a fantastic week. If you are new to this channel, new to the stream, my name is Brandon Satchram. I work for Particle as a developer advocate, and I'm excited to welcome you to the third episode of Introducing Particle, a series where we sort of peel back the covers on Particle and introduce some of our employees and customers and the folks that really make the company tick, to explore our history, to explore the things that we care about in the world of IoT. I'm very excited today to have with us on Introducing Particle, David Middlecamp, who runs our solution architecture team. And David has been a part of Particle for over 5 years and has really experienced a bevy of literally every corner of the company, and worked with a ton of customers over the course of that time. And so I'm really excited to dig into this conversation with him. So let's go ahead and bring him in now. So, hey, David, good morning. How are you?
I'm doing well. How are you doing today?
I'm doing fantastic. Fantastic. Thanks again for coming on. Really appreciate it.
Yeah, thanks for having me. It's a pleasure to be here.
So, as we get started today, it would be great if you could introduce yourself, what it is you do at Particle, and then talk a bit about your background. Sort of how you got to this place in your career where you're doing IoT stuff all day long.
Yeah. So, like you said, I've been at Particle for almost 6 years now. Started really early. I think I was the first software engineer that Particle hired that was doing just software engineering work. I've worked on, like you said, kind of everything at the company, and I can tell as we go through. In terms of my background, I like to say that I've been using computers since I was 3, programming computers since I was 10, do it since I was 20. And kind of the rest is history. I've been in a ton of different industries, marketing to high performance built software for folks like the World Fund, as well as like some governments. In college, I studied computer science, but also theater. I've done a lot of musical theater in the past, so
Nice.
it's I think there are a lot of musical folks at Particle. I think it's
Oh yeah,
not.
definitely not. Well, yeah. In our last episode, we talked to Doc, and Doc's background definitely is very much on the musical side of things, which is really cool. That people that come from the music background do a lot of times tend to find their way into electronics in general, just because it's sort of fun to explore the audio side of electronics. It's not something that I am too familiar with, but I've seen that again and again where people come from that space, and it's pretty neat. So I mentioned Doc, one of our co-founders. How did you actually meet Zach and Doc, and what led you to join them over 5 years ago?
Yeah, it's a funny story. So I was working remotely for this GIS firm at a co-working space in Minneapolis called Coco, at a location called the Grain Exchange. So this beautiful space where it's almost the size of a football field, and one of the entire walls stock ticker from the 70s and the 80s, the old like flipboard style
Oh,
stock
those are so
tickers.
great. Yeah.
It's really cool. And they had an LED one from the late 80s, early 90s that had been deactivated. Literally, when the stock folks moved out, they cut the wires, they took the computers. And so one of my first biggest hacking projects at Coco and lit back up. We got it going. We connected it. We wrote software for it. I had a call for the sign. So I was working in this co-working space, and Zach Sapala, our CEO, sat down in the desk next to me. He took the permanent desk next to me, and he put this pile of Arduinos out on his desk. And I was sitting there going like, "Oh, we're gonna be friends. I'm gonna be this guy's friend. We're interested in the same things. He's working on something cool." And I also met Doc at Coco at the same Grain Exchange. He was working for different startups at the time, and so we like knew a lot of the same people who were in the same space. In the early days when they were working on the Spark socket, I was chatting with them about it. I met Stephanie Fitch, who was really early back at the time, was like, "Oh, the Spark socket, it's too expensive, it's not going to work. You should just sell a Wi-Fi Arduino board. That's what people want. Because at the time, TCP/IP stack, it was really difficult.
Oh yeah.
This is how I remember it,
Hmm.
anyway. Um, so around that time, those folks went off to Hackcelerator, starting to iterate on the Spark socket. I went off and I started working at a marketing company that had promised we were going to do these hardware digital design projects. We were going to build these huge art pieces. And that, but Zach and the Spark folks team came back with the Spark Core campaign being successful, and they went, "Oh no, we need software engineers. I wonder what David's up to." And so they reached out to me through a friend, and I ended up having I've had the most intense interview of anyone at Particle. I'm not sure it's still true,
Uh-huh.
but it was a very, very tough interview. But I ended up getting the job, and
Very
the rest is
nice.
history.
So it's funny you mentioned actually explaining what you remembered of those early days, with Wi-Fi and building prototype embedded projects. It's actually funny. I don't think you're alone in that. We may have our memories colored by our association with Particle, possibly. But what I like to say when I go to events is that when I discovered Particle as a customer 5 years ago, the state of the art was you bought a $35 Arduino Uno and a $65 Wi-Fi shield that you put on top of it.
Right.
And so
Yeah.
you were 90 to $100 in just to get served with Wi-Fi. And when the Spark Core came along, it was like $40 for Wi-Fi. Oh my gosh, absolutely! Like I'm in. That's great. So yeah, I
Yeah.
don't think you're alone in that. I definitely think it's been amazing to see this trajectory of how Wi-Fi and connectivity has become just table stakes built into every device now, and the role that Particle, and then before that named Spark, helped to drive some of that. So along those lines, and I've asked this question of our other two guests so far because all three of you and Mohit and Doc, are all early members of the Particle team. So what were and you answered this bit already, but post joining, what were the early days of Particle like from your perspective as a software engineer, really helping to bootstrap this hardware focused company that really needed your help to take that product to the next level?
Um, it was, I might have some rose-colored glasses. I know we worked some pretty intense hours. Unusual for us to do 80 or 100-hour weeks. We spent all of our time together. We ate all of our meals together. Uh, Will was still in China, helping support manufacturing. Stephanie, Zach, Mohit, and I would sit at this, circular arrangement of tables, working on the firmware, working on the device service, working on all the different components. Favorite memories is at the time we had one Spark core that worked, and the rest were in China, and they didn't have firmware because Will was like arranging
Mm-hmm.
manufacturing. And so we would literally I would test something, and then Mohit would turn around and be like, "Core me," and we'd toss Spark core that existed in the world to the other person, and they would test something, and we'd toss it to the next person. So that was really days where we would have sprint reviews and retrospectives. We're going through, here's what we did, here's what we accomplished, here's what we want to do. And at the time, you got to sit down and hear absolutely everything that was happening at the organization, and logistics, and all this stuff. And sometimes those meetings would go on long enough that I would that had been requested in the sprint planning before the end of the sprint review, before
That's
the end of
funny.
the meeting. So I'd ship it. I'd be like, what else?
Oh,
Let's
that's
go,
great.
let's
Yeah.
go. It was a high
Yeah.
energy
Yeah.
time. It
Yeah.
was a lot of fun.
So that leads to my next question, which I think is a good segue because from those early days where you were primary software developer, shipping features in the middle of meetings, what have you, companies much smaller. How has your role in the company changed? Because you've worn, I know this is an overused phrase, but you literally have worn a lot of hats in your 5 years at Particle. So how has your role changed over the course of your time?
Yeah, yeah, that's a great question. As a first software engineer, I got to build the first version of a lot of our devices and so on. Um, one of the first big changes for me was getting involved in the manufacturing process, which is something that I hadn't done before. So trying to figure out how to actually build a test rig and test something. And Particle actually flew me to China to sit on the test line and like understand what was happening,
Yeah.
which that transformed into becoming more and more involved in the community. Because the company was so small, every time we shipped features, I was literally sitting on the forums waiting people reacted and fixing bugs as they complained, or not, or said, oh, more of this, less of this. So I ended up getting like very, very involved in the community, very regularly, helping explain and communicate what we were doing and what we were working on. That turned into going to conferences, helping run workshops, to meetings with customers. And then it kind of got to this point of like, hey, David, we have so many more people now taking on so many of these projects. I was trying to take off hats as quickly as I could, giving work to other folks so that, it wasn't just so that I wasn't a bottleneck. And then it started turning into going to more and more customer meetings to have these architecture decisions with customers of like, how can we use Particle to be successful? What does a successful IoT business look like? To, at this point, leading the solutions architecture team, which is an incredible privilege and honor. I work with some really talented, by the way. Um, but it is, it's a real job. My my goal for myself at Particle that I've set over the years was to try to focus on whatever was most important
Mm-hmm.
at the given moment. When there are so few of us, you have to triage. You have to constantly prioritize and juggle whatever it is you're working on to try to pick the thing that is most
Mm-hmm.
critical. Go organize your sock drawer while someone's on the line with
Right,
like a critical
absolutely.
issue.
And everything that you just described, I mean, I can look at, where we are as a company now with over 100 employees, and I can look at a lot of what you just described and see how I see mixes of you were doing developer advocacy and marketing and sales and community outreach and developer support and all these things where we have not in some cases not just individuals but teams of people where are doing some of those
Yeah.
things. And so it's definitely interesting, and I've been a part of startups as well, and so to have those experiences where you're in sprint reviews, writing code, and then on, customer calls later the same day, trying to help close a bigger deal, that can be sort of interesting. But I'm sure it's nice to get to that point where you feel like you can specialize a bit in an area where you feel is very important to the company, which is where you are today in solution architecture, right?
Yeah, exactly. To me, the SA, team is the most important thing that I can be
Mm-hmm.
doing right now at Particle. I think we really focus on supporting our largest customers who often have the trickiest questions or have the most at stake at getting the right answers to these questions. If we're constantly learning new things about industries that maybe we haven't interacted before, it gives us the opportunity to go possible level you could go to of, hey, should I have this kind of capacitor, this kind of capacitor? Should I have this kind of sensor, this kind of sensor from this vendor? All the way up to the 10,000 foot view of the business of, how am I going to transform my business? How am I going to, what should my customer experience be? How do I position myself against a competitor?
Mm-hmm.
Um, so it's really an honor, and I'm really lucky to work with such great leadership and such a good team. It's really nice to um, have such a great engineering team at Particle that I know I can trust really fully,
Yeah.
to take good care of, and expand and like build all this stuff that we never
Yeah.
pictured back in the day.
So you hinted at this a little bit, and as the lead of Particle Solution Architecture team, you're describing already some of what you all do. But how would you like? What's your elevator pitch to when you get on with a new customer? How do you describe the value that your team provides not only to that customer, but to the sales team as they're engaging with a customer during the process?
Everyone in that meeting, different incentives is to advocate, make sure that they feel good about you, but you also, as an employer or as a vendor in this case, you want to, you're interviewing the person, you're a good fit for them as well, and that you're going to take care of them. In the sales context, in these meetings, we're trying to figure out, it's not trying to fit a round peg into a square hole, or vice versa. What is it that you're trying to do? What are your business requirements? How can I advocate for you getting what you're expecting and buying what you're expecting? The goal for us too is to be able to say, at the end of a meeting, here's a document that shows you in flowcharts or bullet points or paragraphs of text, here are all the requirements that we think you have. Here's the scope of this arrangement. Here's about how long it's going to take, cost. Here's how it's going to impact your it's some customers who have like a kind of a vague idea of what they want and leave with a crystal clear idea that they can have confidence in, that they know will work. We've had some customers too that come to us and say, if we think we do this, it's going to have this kind of benefit. And after going through the books with the sales team and their business team and their marketing team, walking away saying, actually, if you do this, you're going to make $30 million that you don't even realize. So I like to think that we are an incredible value add as an advocate who's really advocating for both sides in that. Not sure if I answered.
No, you absolutely did. And it actually made me think, one of the things that I've always found most fascinating about the work that your team does is that we encounter a lot of folks, and I think this is probably true of IoT in general, but there are a lot of companies out there that come to a particle or they come to another connectivity business or connectivity platform. They chase this idea of IoT, believing that it has value for their business, whether it's cost savings or new revenue opportunities, but they're not quite sure how it has value, or they don't quite know how to get the rest of the way there. And so one of the things that fascinates me about the work your team does is that you all are being approached by customers that know they want some of that IoT, but they don't know exactly what it looks like, and then you guys have to come in and help explain to them what it is. These can be a lot of businesses that they may have a manufacturing discipline. They may even have, embedded hardware and microcontrollers that run parts of their business, but it's that connectivity and platform and insight piece that they don't have, where your team can really help them understand how to unlock that next piece of value. Would you say that's accurate?
Oh, absolutely. We work with a lot of, what are often called traditional product companies, where maybe they have mechanical, even have electrical engineers, but they've never even thought about, do I have to write a mobile app or a web app? What does it mean to host something in the cloud? What do you mean that I have to pay for a SIM card now because there's cellular connectivity? So really entering some of these companies. In some cases, we've literally helped some of our customers interview and write job descriptions for people that they need to hire to actually enter this space. And it's been, we go pretty deep. It's pretty comprehensive support.
Yeah, that's and more comprehensive than I've ever seen, which actually does, I think, lead to my next question, which is, a lot of us, I have a similar background to you. I came much more from a software side, getting into hardware more in the last 5 or 6 years. I know a lot of folks that I've interacted with on Twitch and on other platforms as well tend to be software folks that are interested in hardware as well. So many of us have spent at least a part of our career either aware of or in a role that's similar to a software architect's kind of role. And what your team is doing is architecture, but it's that IoT solution design and architecture. So what are some similarities between IoT architecture and software architecture? And then what are some key differences that you and your team have learned over the last few years?
Sure. As you've probably heard this a bunch of times, is that hardware is hard. If you look at the difference between software, firmware, and hardware, those names are not an accident. Software is soft because it is changed and quickly updated. Firmware is a little firmer than software because it's often a little harder to change. We like to think at Particle that we make that easier. And hardware is hard to change. You actually have to make something in the real world, which has all kinds of considerations that most people have never even thought about in a software context. You can't literally just call a factory and say, make me a thing, and where every single component is coming from, why you're picking those components, the characteristics of those. A good expression I've heard too is, oh great, now you've invented something, you've built a prototype. Now you have to invent a thing to make that thing, and you have to invent another thing to test that thing. The factory doesn't know how to build your product just because you built a prototype. You have to design a system for them to do that. So there are all these components around actually physically in the real world, which is really challenging. At Hacks, they like to talk about, the hardware death valley, where you raise enough money to cover your bill of materials, but then you've forgotten about all the other costs involved of not just buying components, but storing them, keeping them dry, reworking things, designing things, tooling, this whole other world. And so there's a range where a lot of startups get into, and you'll see this on Indiegogo and Kickstarter and CrowdSply, where they raise just enough money, but not actually enough money to make the thing. And so a lot of companies have to go out and get more funding, or they have to justify this business case. So that's like a big change. So a lot of what we do is actually helping them understand what it's going to take to bring this thing into reality from a business perspective. So if they don't have things in place, making sure that they crawl before they walk, they walk before they.
Yeah. Mm-hmm. Yeah.
And folks,
absolutely,
one leg out there.
This aspect of hardware has always been fascinating to me. I actually got to take my first trip to China about a year and a half ago, and not only got to spend some time in the Huachong Bay market, looking at tiny little LEDs and capacitors that you could buy in the tens of thousands for micro fractions of pennies on the dollar, but also getting to see some of the actual manufacturing process. And I think, as someone who spent most of my career in this world of zero distribution cost, when you ship software to a server, then your work is done in terms of cost and scale. Now you are infinitely scalable as long as your server will hold up. And if you need a second server, then great, just turn a knob, add another dyno to your Heroku instance, as I used to say, whatever it needs to be. But what you're talking about, and I love a few aspects of that, because it's one thing that I've seen, and I've heard people comment on this over the last couple of years, this idea of sometimes creating the test jig for a piece of hardware is more difficult than creating that hardware in the first place. Because designing the thing, that's difficult, but you kind of know what you need it to look like. But then you have to build something that automatically tests thousands of the thing. Good luck with that. That's going to be fun.
Yeah. And it's to working with some of these really fantastic vendors in China and other parts of the world. There are people, I'm in this position where I have to know a little bit about a lot of things, which is a big difference between being an SA or just being a software architect. There are folks that spend their entire career becoming masters at things. That you can give them a rough idea of here's where my pins are on my PCB, and here are kind of the things that I want to test. And in something like an afternoon, they can knock out a mechanical test jig for your factory line tester. And they do this for a couple $100. Wow. They're incredibly fast and incredibly accurate and skilled. Yeah. And then you can build your test rig into that. And there are companies in the US that might charge you, $250,000 to do a product. Whereas if you're scrappy and you're doing it yourself, okay, maybe you get somebody to knock together a test jig for you. Maybe you spend a few months, a few $10,000 to do it. But yeah, it's really a lot of work to build those test jigs. I remember, I worked with Mohit and Will in the first test rig, we started on the BeagleBone Black, which was this really powerful. And we were dealing with all the things that you deal with using a single board computer in a factory setting on the other side of the world. And at one point, I flipped a bit on one of the GPIOs. I changed it from a floating thing to a pull-up or something. And there was an undocumented side effect on the BeagleBone Black that changing that GPIO knocked out the Ethernet port. And so I deployed this thing to the test rig. Will was sitting in China at like 1 a.m. in the factory in the dark. There are literally like, small animals moving in the shadows, like rats and stuff in the factory that he was trying to.
Yeah.
And we deployed this update to fix this like very minor thing, and all the test rigs like went offline.
Oh.
And I had no idea why. It was just one of these like, no. There are all these little problems that you can't expect. Like, you just have to give yourself time. You have to be patient.
Like you said, hardware is hard. I mean, I don't think any of us can really develop an appreciation for it until we actually get into the midst of it and realize. I've experienced it on a much smaller scale, but even with some of the things that we did last year, like some of the badges that we created for conferences and whatnot, when you got to that point where you're like, oh, I just ordered PC. Yeah, there you go. Yeah, the badges. Yeah. When you just spun new boards and they show up and you're like, oh, crap. I totally did something wrong in the layout, and that transistor has been rotated and it's going to completely short the board. It's going to be another 2 weeks before I can move any further, right? And I think those of us in this space have developed an appreciation for the startups out there, the Kickstarter startups and others that have encountered many of these problems where it's like, we apologize, we're delayed again. And here's why, because these things, they have cascading effects, I mean, that's just sort of the reality. But it's interesting how you and your team have been able to take that, because we have, through those early days of you and Will experiencing how small changes can spiral. I think we have built some institutional knowledge that your team is able to help customers really think about when they're new to this process and they're really trying to navigate their way through it.
Yeah, absolutely. And I think that's often what folks are looking to us to help provide. In my career, I've been lucky enough to work on, production websites, desktop applications, mobile applications, tablet, all this different stuff that's actually shipped to production, has been used by people in the world. And I've had the opportunity to maintain and fix. And I think that's actually a really key learning point. This is something that I talk about a lot, especially as I'm interviewing folks, where a lot of software engineers out there who are doing something for the first time, haven't had to support their own mistakes. Everybody makes mistakes. It's going to happen, even the smartest, best people in the world. But I think having the opportunity to support your mistakes and correct your mistakes and understand how it impacts them is incredibly valuable. Like, it's completely changed how I do component selection, or I pick a library. It's changed, when I recommend, like some folks out there, I might wait 6 months before I upgrade to the next version of Windows, because I know that they're going to go through deploying fixes and patches, and that's normal, and that's great, and that's fine. But I don't want to do that to my production server.
Right.
Little things like that you learn the hard way the first time around.
Yeah.
And so being able to give that advice to customers, or see someone doing something and saying, like, what you really should have is a staging environment. Why don't you pick that you get along really well with, that has a lot of devices, that's tolerant of mistakes, and you can test your firmware there before you deploy it to all of your customers ever. Like, little things like that end up being really valuable.
We got a comment in chat agreeing with you. Wicked Kender, hey, happy Friday. Says it's always rough to be on the bleeding edge. And that's absolutely true. In Particle, and the experience that you shared earlier with the early days of Particle, I think we definitely were on the bleeding edge in a lot of ways. But it has had the benefit of giving your team some really critical insights. Which, along those lines, one of the other things that I wanted to emphasize is something that drew me to Particle in the first place wasn't just the inexpensive option of a Wi-Fi dev kit, but was all actually the tools and platform around it. And I want to talk to you about this in particular because I know you had a hand in a lot of these early developer tools. I always like to tell people that Particle is the software developers IoT platform because it has tools and services that are designed to make this whole world less intimidating for people like me. And I think a lot of that is probably because you come from a similar background, a software person trying to break into this space. And a lot of us, I think, love the ease of the tooling and the platforms and the SDKs and all of that. And I can see how that, I think one of the follow-on effects of that in your team, and this is what I would love for you to unpack, is how often you all encounter customers that maybe don't think beyond just that piece of hardware. And you've mentioned this a few times, but where they really need to be thinking about the device and the mobile app and the cloud, server, and where the data ingestion pieces are and what they're doing with their time series data. Everything beyond the device that in many cases is a lot more work and time and effort than just that piece of hardware itself. So how often do you have those kinds of conversations with customers?
Really, really good question. That is honestly, that's really frequent. So in a typical conversation, on any one particular meeting, we're maybe talking to a handful of engineers or a customer. So they're always going to ask us questions about their domain. So we might be getting electrical engineering questions or cloud questions or so on. But it's really typical for us to be talking about, people will ask me for like Swift advice for iOS development, and I've never done Swift development. I get asked about like, hey, should I use Kinesis, Kafka, or Spark? Should I be using DynamoDB versus Mongo versus Redis versus Redshift versus, Postgres? And like, fortunately, I'm like a little familiar with the database stuff, so I know that. But we cover, we really have to cover everything. And I think, one of the important things we do on our team, to be honest. So if somebody asks me a question about something I have no idea about, I will say like, hey, I don't know. But I'm going to find somebody who does. I'm going to help you answer this question. I'm going to help you move forward. And there are some cases where, sometimes we help rescue folks that get into a bad situation. I had one of my favorite customers, a consulting partner built them a cloud solution and then kind of disappeared. They weren't there to support that cloud solution and they were having a problem. And this customer pinged me and I kind of jumped in. And I hadn't seen most of these tools before. It was somebody who kind of built something and said, I'm going to use every brand new service, that Azure has to offer, or that like Google Cloud has to offer, all the new buzzwords, everything that got it announced at like the latest con. And so it took me, we kind of jumped in and did a complete analysis and tried to figure out even just all the services and components that were turned on and what was talking to each other and how data was flowing, and then like twist to actually fix it. And we ended up fixing it in about a day. We're often just completely thrown into, the deep end of the swimming pool, and you gotta swim.
Yeah, got to help the customer sort of unpack their issue and get them unblocked, get them past it. Definitely. So, what are some of the most common types of problems? And I know this is hard because you talk to a lot of different types of customers in several different areas, but do you see similarities between classes or types of problems that customers bring to the table?
Yeah.
Yeah.
Yeah, absolutely. There are a bunch of common issues that I see. That's really interesting is I think at Particle we make connectivity look easy. Things like over-the-air firmware updates and real-time two-way communication, it just works most of the time when you use Particle, which is wonderful. And so we see folks get something going and they say, hey, you posted your bill of materials online, so I'm just going to go build it myself. Bye. And we don't hear from them. And long enough that this has happened about times, where in about 9 to 18 months, they call back and they go, so I threw $1 million down the drain. I don't have something that works. I think we should have bought Particle originally. Will you please help me? And this happens over, and at this point now when a customer says to me like, I'm going to go build it myself by, I was like, now working to make this reliable and easy site reliability engineers who literally get paged in the middle of the night if anything goes
Mm-hmm.
wrong, things that we can't control, that they're reacting to and dealing with. So I try to remind customers like, do you really want to be woken up in the middle of the night when a hurricane takes out a data center, that you couldn't have predicted?
Right.
Another big often don't read the document. In terms of selection, try to find the cheapest of something. So they see that they can do something with a particle photon and they say, I'm going to go buy an ESP8266, and they don't realize that like, hey, the documentation's not there or the libraries aren't there. There's an amazing community that's built up around that. So I don't know if that's still
Mm-hmm.
as true, but um, we pick vendors that we know are going to be reliable, a test of time, and to also de-risk our supply chain. One of the things in hard is there are all kinds of issues that happen around the world where, hey, maybe there's a capacitor shortage or there's a shortage of some component, and we have a team of folks making sure that things still run smoothly, even if that's the case. But one of the biggest problems that I see is people don't risk case.
Mm.
A great example is, hey, I want to make a connected cat litter box that tells me when to change my but I haven't thought about how am I going to pay to host my servers? How am I going to pay my mobile app developer to make me a mobile app to act with this data? How am I going to train my machine learning cat litter notification system?
Mm-hmm.
So I think really thinking through your business case, thinking through someone with it is a really important step too before you get too far.
Yeah, definitely. And along those lines, I had a conversation last month with Doc, and it was specifically about it was about a lot of similar things, but we drilled in on IoT security for a little while. It was a talk that he gave
Sure.
in October last year at our Spectre Developer Conference, and I wanted to follow up on, and I wanted to ask you a few questions about that as well, because I would be willing to bet that either you have customers ask a lot of questions about security, or you have to offer advice at times, but what are some of the common things that come up in the IoT security space when you are talking to customers that are considering getting to IoT in general and evaluating Particle?
Yeah, that's a really good question. Um, there are different categories come up around security. I don't want to sully the name of Pampers Diapers by accidentally leaking something critical. There's a category of customers that are worried about PII, personal information. They want to make sure that that doesn't leak or get out into the world or compromise or provide a competitive advantage to their competitors. There are a lot of folks in different industries that are bound by really strict regulations. So you have the new data privacy laws in Europe, companies that have to make sure that they're not storing anything that's like patient identifiable. And then there's a huge category of companies, especially in the Fortune 5000s and up, where they've been around for 30, 60, 100 years, and they have strict regulations and compliance practices around how they operate internally, the compartmentalization of data. Are you SOC compliant and so on? So we actually have to do a lot of work for some of these companies to demonstrate here's how we're auditing things internally, here's how we're doing change control, here are some of our security practices in terms of not just how we protect our software, but how we physically protect our
Yeah.
employees and our workstations and our assets, what kind of accountability we have in place, how do we notify things. Um, it's been really fun working really closely with Doc over the year of Particle. It's something that I'm really proud that I know he's considering all the time and really incorporating into, not just the new things that we're building, but like day to day how we
Yeah.
operate.
That's been one of the things.
Your question, well,
Oh, no, you absolutely did. And that's actually been one
okay.
of the things that I've been impressed with as well as seeing that we continue to try to make strides in that area. I'm being a homer for a moment, but when there are when there are stories every day that pop up around new or not new, but IP cams from Chinese manufacturers that have P2P turned on by default and you can't turn P2P off, and
Oh,
they call home to servers overseas, and they have
right.
default passwords that are printed on stickers on the devices.
Yeah.
Um, it impresses me that, and I'm not just saying it's not just us. There are an increasing number of companies out there in the IoT space that are trying to be conscientious about this. And what I
Mhm.
appreciate in particles, in the particle environment, is that we have enabled two-factor authentication in the last several months on our
Mhm.
services. That when it comes to the new mesh-based devices, that we have the devices secured in such a way that in order to get a new device on a network, you have to have physical access to the device and a network
Mhm.
password. You need to have
Yeah.
that two-factor piece for mesh as well, which is really which I really appreciate, and I think that it helps tell a better story, the positive side of where we think the IoT is going in a
Mhm.
lot of ways around the world of security.
Yeah. I'd love to share a couple quick security stories if it's
Yeah.
interesting. Um, I don't know if folks know this, but one of our early particle advisors, Spark advisors, is a man.
Mm-hmm.
If you aren't familiar with him, I strongly recommend Googling him. He is working on some really, he seems to always be working on some kind of amazing project. And uh, one of my favorite at CCC in Germany was he was showing a teardown that he did of an SD card. And you can't just by watching the video, but he's giving the talk on a laptop that he literally designed and built from scratch, that he wrote all the firmware for all the components for, like attached to the SD card using a flex PCB that he designed and made himself. He the SD card and the X-ray of it, like with his decapping skills, he fuzzed the SD card, like checking all the inputs on like a fuzzer he wrote on an FPGA in a board that he designed and built in his custom laptop. And he's giving the presentation on his laptop. And it's just like the most Hollywood-esque, you know, uh, thing. But he's also like just an incredible guy. And he's an advisor for Particle. He helped us in the early days design our initial secure. It's actually as secure as we want, or as secure as it needs to be, rather, as well as guiding processes around how do we capture, measure, and use entropy on our manufacturing lines. Because in the early days, we were actually generating encryption keys on the manufacturing rigs for the manufacturing
Wow.
process. And like, how do we write those keys in such a way? How do we securely destroy the private keys but only store them on the devices? For the years, I've literally had engineers from Apple who do this at Apple approach me and say like, "Are you doing this? Are you doing this? Are you doing this? Are you doing this?" And I'm like, "Oh yeah." And they're like, "How did you know to do that?" Like, we do that. How did you know to do that? Um, and so it's like a moment of like, we really thought about this from the absolute beginning. And I've given workshops and presentations too because our firmware is open source, our protocols are open source. I've had people raise their hand and go, on line, 350 of such and such communicate here, like you return a one instead of a zero, and I think that's a bug. And I'm like, no, it's not a bug, and let me tell you why. And I like pull up the code and we like go through the thing. So it's really a privilege to have such an incredibly like caring and involved community to help like make sure that we're not making
Oh yeah,
mistakes.
for sure. And yeah, so there was a question in chat. James, hey James, hope you're having a good Friday. Is this Bunny you're talking about? And yeah, I know you may have just popped on, but yeah, this is Bunny Wong. And if anybody watching, if you have not read Bunny's book, The Hardware Hacker, find it on Amazon. It's an amazing book. It's
Mhm.
worth a couple of different reads. I have it on my bookshelf. I know that
Uh,
David does as well. Uh, Fantastic.
yeah, guide to Shenzhen around
Oh
here
yeah,
soon.
I have that one too. Yeah, I backed his
Yeah.
crowd supply project for that one. But that's a great resource, and I think a lot of the things that he learned in his days at Chumby and working on Novena and others, I think definitely helped Particle out in some of the advice that he's been able to give. Um, on the security
Right.
front, I want to underscore what you said about the caring community, because we have, and I know you and Doc and others have fostered this. We have a security email address, security@particle.io.
Mhm.
We get emails from the community at that address when people notice something that might be an issue, either in something that, whether it's even a piece of content or in code, and we reply to those, which has been really neat to see. I've actually been party to a few of those emails as they've come across over the last year and a half. It's really neat to see our community that just conscientiously wants to make sure that we know if there's anything that they think that might be amiss. And so that's really neat that we have a community that's willing to help watchdog us a little bit, and that we in turn, want to create products that the community can trust and actually rely on. On the security side,
Mhm.
at Wicked Kender made a couple of comments here as well. They mentioned that they work in K through 12 education, and they were mentioning sort of the physical side of security, and how the IoT is
Mhm.
helping their company look at things like gunshot sensors, student body tracking, smart access control. These are things that we didn't wish had to be, that we wish did not have to be solutions that were built in today's world, but they are.
Yeah.
And the physical side of IoT security is an interesting thing. Is an interesting thing as well. Have you had any conversations with folks that are looking at the physical aspects of where IoT can actually help secure facilities, workspaces, what have you? I know you've mentioned you get asked about our own physical security practices, but what are some of the things that you've seen along those lines?
Well, in particular, and it's interesting too that you mentioned security. It makes me wonder, when we talk about physical security, or unlocking a door
Mm-hmm.
or a lockbox or an asset like a vehicle or something. That's one aspect of security, but another, and we have customers doing all those things. But we also have the physical aspect of security of how am I keeping someone safe? Air that they're breathing safe? Is the
Mm-hmm.
water that they're drinking safe?
Mm-hmm.
Is their home flooding or on fire?
Mm-hmm.
And those are use cases that I think are such easy wins for IoT.
Mm-hmm.
Um, that are things that like insurance companies can really easily get behind. There are so many businesses that have really strict compliance needs. Like a good example is you picture an auto body shop that paints cars, right? And they're using these sprayers that spray paint on the vehicles and accidentally have too much paint dust in the air. You could accidentally make the environment explosive. You could make the environment poisonous. It could be poisonous for somebody
Mm-hmm.
to breathe. Somebody might not be wearing necessary safety gear. And so little monitors that are smelling for, is there too much of this chemical in the air? Is there enough oxygen for people to breathe? Um, could on one front just be alerting people, but now because you have these microcontrollers, because you have this connectivity, you could be turning on windows, you could be bringing in fresh air. So in terms of that physical security, in terms of safety and compliance, we see a lot of that. And then you can even look at the macro scale. One of the customers that we love to talk about is a company called Opti
Mm-hmm.
that's literally doing safety for municipalities, for cities.
Mm-hmm.
So, in anticipation of a heavy rain, they're redistributing floodwaters between cisterns and catchments to help make sure that so there are things on a big scale as well as a small scale. One of my favorite, companies out there that started doing gunshot detection early is a company called ShotSpotter
Mm-hmm.
that you're probably
Mm-hmm.
like, but it's also incredibly expensive. And so if you were a school, if you're an education, house that's education house, that's not a term.
I get it.
Academic
Right.
institution. There we go. If you need to build a sensor like that in a school, you can't be spending $100,000 on every sensor. You need to be able to spend sensor like making these kinds of traditionally enterprise or large scale solutions accessible. It is really
Yeah.
important. Um,
Yeah. We got a comment in chat from Codacy. Hey, Codacy, thanks for commenting. It said thanks for making the schematics and design open source. It helped us at Streambeam make our PCB for our river gauges a bit quicker. So I love to hear that, because I wasn't involved in those early decisions. I'm sure that you were, David, in terms of trying to be open as much as possible where it made sense. But it's nice to see validation from the community that's actually helped people build solutions by taking that open approach. which has
Thank
been really
you. I
cool.
really appreciate you saying that. I want to give all the credit here to Zach and Zach, our awesome co-founders, who really believed in the power of open source and how that could build empowering more folks. I think hardware for a long time has been, really traditionally locked down, and the knowledge there has been really institutionalized. And I think just having open hardware, being able to throw something in something like Eagle or KiCad and understanding how you can make it yourself is so critical
Yeah.
and so important.
Well,
Um,
and
yeah,
I know that love of open is what led us. We've had a long relationship with Adafruit, and I know that you and I, when we announced the new particle mesh, our third generation devices, we're definitely very jazzed about this. Our use of the feather form factor. It's something that I have leveraged a lot. I know that you have as well. And that actually leads me to my next question because I wanted to ask you, sort of turn to fun for a moment. You've worked on a lot of different projects over the years, for booths, for Maker Faire, for different conferences and demos. Um, can you share a few of your favorite projects that you've hacked together in your time at Particle and some of the fun things that you've gotten to do?
yeah. It's That's a great question. Um, so in terms of like fun builds, every year we try to do an April Fool's project. So I've been involved in a lot of those. They've been pretty corny for a lot of reasons because I'm terrible at video editing. But we made a Morse code telegraph button that was Wi-Fi connected. I made a particle connected cement block that was really fun. I literally entombed an electron in
That's
concrete,
great.
which was pretty funny. I started to work on an April Fool's project, but it was going to be a particle 56G instead of 5G, which was going to
That's
be a 56K modem connected
that's great.
to particle hardware, which was going to be fun,
Yeah.
and maybe try to set up like a bulletin board or something like that. Um, we also build really cool stuff for Maker Faire. So we made this huge interactive marble machine, and a bunch of the engineering team got involved, which was really kids really had fun with that because there were all these like huge buttons, and here a bunch built a physical version of Space Team,
Yeah.
which is a really fun game made by really nice guy. He's working on a new game now, but if you haven't played, I really recommend it. It's free. It's an excuse to yell space-related gibberish at your friends in public. And it's such a fun game that I wanted to build a physical version. So we built all these, aluminum cases with like lights and buttons and switches on them. And that was another one where a ton of folks from the engineering team came in, really awesome things like LED animation over here, sound effects over here, a wired protocol to communicate over there. An awesome project to build. I just got to show that off again in Miami at the
Yeah,
Miami
Miami
Maker
Maker
Faire.
Faire. Speaking of which, so Mario the Maker, I assume is our friend Mario from Miami, said David is the man.
Oh,
And yeah, that Dave brought Space Team to Maker Faire Miami, which has been cool. I got to see some pictures from that. It looked like it was well received there, as it was in California last year. And then we also had it at that conference in Wisconsin
oh
last year. We
yeah,
had a
yeah.
few of those. So that's a neat project. The marble machine was before my time, but I saw videos of that as well. And I think that's always, it's fun. I think one of the things that get a lot of us in this space to begin with is either we're looking for an avenue to get kids and younger people excited about physical computing, which is I know why a lot of people get into the maker movement or the embedded space. But I think also it's because we want to scratch an itch, whether it's with smart home or whether it's building a game or a piece of hardware that solves a problem that's unique to us. And one of the things that you've done over the years that I think has always been impressive and engaging for our community is taking that idea and really embracing it and run with it. We may build fun demos that it may be two steps to talk about how this applies to a larger customer in an enterprise scenario. But at the end of the day, you're ultimately still using the same sensors and actuators that you use on a machine floor. You're just doing it for something that draws people in, that's
Yeah.
engaging, that sort of shows them what's possible with this entire world of IoT, which is pretty neat. So it's not really a question, more of just a thank you and a comment for inspiring the community in that regard. Um, As we a couple more questions as we wrap up, I wanted to ask, what are some resources that you recommend? We mentioned Bunny's book already, The Hardware Hacker. I think it's an amazing book.
Oh yeah.
But what are other resources that you recommend for anybody that might be interested in getting into IoT architecture and system design? Someone that's looking beyond just not an intro to electronics book, but like thinking more broadly about what it's like to build a system end to end.
Sure. Um, that's a really tough question. I think we're still in a time where um, a lot of things are getting more and more special that are um, together. So I don't know that you're going to find a book on a shelf that says, here's how you build a mobile app and a cloud service and a back end and a piece of hardware and pick sensors and build a testing rig. I think that's you're really covering a huge, broad topic. My advice that I would give is honestly try to find mentors. Look for folks that specialize. Hang out with them, learn what their job is like, build a project on the side. In terms of we're a huge fan of SparkFun. They both make content and tools and guides, and the folks at both those great makers on and which like lessons and builds how to be a maker. In particular, I think I'm one of Simone Yurtz's patrons. I like he's doing. I'm a big fan of Adam Savage Tested. There are a ton of to remember. Electro Boom. It's really fun. There are lots and lots of good stuff.
Yeah.
And honestly, too, Make Magazine was there for me when I Collectibles was there for me. Hackster is there. All of really good examples.
Mm-hmm.
I think my best advice is you might be frustrated building your project for the first time. So I would encourage you to pick something that you're about and let that energy, let that excitement carry you through the frustration. If you know that your favorite thing in the world is ice cream and you want to build an ice cream making machine as your first project, let that excitement about ice cream carry you through trying to figure out why you bought M3 screws instead of M2.5 screws and that doesn't fit, because it's off by half a millimeter or something crazy like that.
That's fantastic advice. And taking that approach got me through a whole lot of custom PCB design failures as I was working on my first homebrewing project many years ago. So yeah, I think that's absolutely right. When you find something you're passionate about, you'll see it through the low moments because it's going to be worth it to scratch that itch and solve that problem. So yeah, those are all wonderful resources, definitely.
Thank you.
So last question, and this is the last question I ask everyone that I've interviewed so far. At Particle, we like to talk about this concept of real IoT. The term IoT has been dragged through the mud over the last several years. It's definitely gotten a bad reputation in some spaces, but we like to talk about how we continue to find over and over again customers that are solving real problems with IoT, using connectivity in a way that wasn't possible before. So what is your definition of real IoT?
We talked about this a little bit earlier in terms of physical safety, and I think the IoT that we're seeing right now, as an industry, I think IoT is very much in the 80s, early 90s. If you think about the boom of personal computing, businesses are just discovering business cases. They're just figuring out how they want to transform and change their businesses. Cases that I think are really real and are impactful, use cases that I think will affect your life in the next 5 or 10 years are the things around safety. So how do I make sure that my water's clean, that my air is breathable, that my city's not flooding? How do I make sure that I'm keeping my hospital safe or departments or circumstances out of our control? You might not realize this, but there's a lot in our world that we depend on right now. We need that pump to not fail. We need that, we need that building circulation system to not fail because that's actually protecting lives. They're such easy to justify use cases that I think you're going to see a lot of that. My favorite example here is seatbelts. Seatbelts became a thing because they save money if people didn't die in car accidents. And so they pushed. I mean, that's my
Yeah,
basic understanding.
yeah, yeah.
Somebody probably watching the Twitch feed is like, no, it's actually because of this. So please correct me if I'm wrong. But this is what I've heard. And so I believe that you're going to see that with IoT. Insurance companies are going to figure out I don't have to spend as much money if I keep you safe, if I keep your drinking water clean, if I prevent your house from flooding, if I make sure the firefighter shows up before there's real damage. So I think you're going to see a
Hmm.
lot of that, and I hope we will, because I think that's going to make everybody's quality
Yeah,
of life better.
absolutely. I love that. I love the way of looking at that. So, David, I really appreciate it once again. Thank you for taking some time out of your Friday to hang out with us here. Thanks for the folks in
Yeah, thank you
chat
for having me.
for saying hello and asking questions. But yeah, David, it's been wonderful. I hope you have a great rest of the day, and we really appreciate it.
Thank you so much for having me, and thanks everybody for joining. It was great hanging
Awesome.
out.
Well, everybody, thanks again. We'll see you again soon. We'll be posting a schedule of upcoming episodes very, very soon as we talk to other folks on the team. And again, have a great Friday. Have a great weekend up ahead. And we'll see you again next time. Thanks, everybody. Bye.